Section 3.4 focuses on slope. So slope is really another way of saying rate of change. The change in x that goes by this amount leads to this change in y. Example of something that could be seen as a slope is how much money you make per hour at a job. For each additional 1 hour I work, I make $12 additional. That would be a linear equation where the slope is 12, telling me that if I work 3 hours, I should get back $36 because it should go up 12 for each of the hours. So some things we're going to be looking at is finding rates of change, finding the slope of a line from looking at a graph, finding the slope of the line if we're given 2 points. We're going to have a formula that we can put into it. Recognize positive and negative slopes just in general. Find slopes of horizontal and vertical lines. Use slope to graph a line and determine whether lines are parallel or perpendicular using their slopes. So let's start by trying to find the slope of a line from its graph. Slope of a non-vertical line is the number that measures the line's steepness. Basically everything is put in terms of how many units do I have to move up or down as I move this many units to the right. So we calculate the slope by picking 2 points on the line and writing the ratio of the vertical change, called the rise, to the corresponding horizontal change, called the run. Rise over run. As we move from one point to the other. As an example, we'll try and find the slope of the line that was used to describe the number of building permits issued and show that it gives the rate of change. So this is showing that if we start at 0.4 and go up to 12.40. So here is the line that we're trying to find the slope of. We can write from this point to this point, there was a vertical change. It went from a value of 4 to a value of 40. 40 minus 4 means it went up a total of 36 units. The vertical change was 36. We started at an x value of 0. We went over to an x value of 12. From 0 to 12, or 12 minus 0, means we had a horizontal change of 12. So our rise up was 36, our run to the right was 12. That means as rise over run, we would get 36 over 12. This is showing how I could see it as a ratio. Change in y values over change in x values. The y value went from 4 to 40. So 40 minus 4 represents that change. The x value went from 0 to 12, so 12 minus 0 represents that change. Again, it's a ratio of rise over run, or change in y over change in x. When I put 36 over 12 into a calculator, it would tell me 3. In general, you want to make sure that if this is a fraction, you're reducing it to its lowest possible form. This is the same value we got when we found the rate of change. They're referring to an earlier slide that I deleted because I wanted to get into the skills that I'm really evaluating on. Here I'm asked to find the slope from a figure. The way that I'm going to do this is I want to identify 2 points that are happening at crosses at a corner, I would say, of one of these boxes. So I can see definitely 0, 0. Is a point on this line. This looks like it's happening halfway between something, so I don't want to mess with that. But right here, this looks like a point that's happening in a corner as well. So what I can do is say, if I wanted to travel from this corner to this corner, what would be the rise and the run? So first I want to say rise vertically, how am I changing? So to go from here to here, I'm going down 1. Same idea, I want to find the run from left to right. How am I going? So from here to here, I'm moving 1, 2 to the right. So the rise is down 1 or negative 1. The run is 1, 2 or positive 2. So they're going to pick their 2 points. They pick different ones than me. That's absolutely fine. As long as you pick points that are happening at a corner, you'll get the same correct answer. So where they pick is over here at the point negative 4, 2, and down here at the point 2, negative 1. they see that it moves 1, 2, 3 down in total, so it has a rise of -3, and it moves 1, 2, 3, 4, 5, 6 to the right, so it has a run of 6. If we then take the fraction, rise over run, we get -3/6. 3 goes into both of them. So when we have that rise over run -3/6, we want to put it in its fully reduced form by dividing both top and bottom by 3. -3 divided by 3 gives me -1. 6 divided by 3 gives me 2. So that's how I get to my slope of -1/2. The slope of the line is -1/2. Again, the way we got there was we looked for corners on the line, saw what the rise was, saw what the run was, made a fraction rise over run, and then put it in its fully reduced form. Find the slope of a line given 2 points. So I highly recommend that you have this formula out in front of you when you're doing your homework. Put it in your notes somewhere. This formula will definitely come up on the test, will definitely come up often on the homework you're going to be asked to do on this section. So we can generalize the graphical method as basically, if we call this point x1, x2, x1, y1, and we call this point x2, y2, we can also read that as x sub 1, just saying the first point's x coordinate, y sub 1, the second point's, or the first point's y coordinate, x sub 2, the second point's x coordinate, y sub 2, the second point's y coordinate. If we have that information, then really the rise is just going to be the second y coordinate, y2, minus the first y coordinate, y1. The run is going to be the second x coordinate, x2, minus the first x coordinate, x1. So rise over run is really going to be change in y over change in x, or y2 minus y1 over x2 minus x1. So the rise, y2 minus y1, or change in y, and the run, x2 minus x1, or change in x. That gets us to our formula. The vertical change over the horizontal change, or the rise over run, is really change in y over change in x, which gets us to this formula, y2 minus y1 over x2 minus x1. Understand that in this formula, there's parentheses understood over top and bottom. I want to make sure I resolve the top, resolve the bottom, before I reduce any fraction between them. This says if x2 is not equal to x1. The reason it has to say that is because if I had x2 minus x1 and they were the same, I would get a 0 on bottom. In math, we cannot divide by 0. What we're going to learn is that's going to happen when we have an x equals line. If we have an x equals line, then x is always staying the same and not changing. That would mean I get a 0 on the bottom here, which really means that it's an undefined line. So this formula works for any pair of points, except a pair of points where the two x values are the same. If the two x values are the same, it'll lead to a mathematical error if I put it into my calculator. I need to know that that error is telling me the line is undefined, it's a vertical line, and its slope is undefined. Find the slope of the line passing through 1, 2, and 3, 8. I recommend, as you're first learning this formula, that you label your points. So I would first say above 1, x1, above 2, y1, above 3, x2, and above 8, y2. If you have the points labeled properly and you have the formula in front of you, all you then need to do is plug in where the points go. So, in our slope formula, y2 is 8. I'm going to put an 8 in here. y1 is 2. I'm going to put a 2 here. x2 is 3. I'm going to put a 3 here. And x1 is 1. I'm going to put a 1 there. If you plug these in where they go, you now just have to do subtraction top and bottom and reduce. 8 minus 2 gives me 6. 3 minus 1 gives me 2. If I have 6 over 2, that's going to reduce to 3 over 1 because 2 goes into both numbers. So 6 over 2 is what I initially get. That reduces to 3 over 1, or just 3. The slope of the line is 3. It's absolutely fine if you want to leave it as 3 divided by 1, just so you can better visualize The rise over run, the computer system probably wants you to say that anything divided by 1 is just a whole number itself. So the final answer here for slope would be that the slope is 3. This is showing the 2 points that we were going between. The rise was 6, the run was 2, which gets us to a slope of 3. So here they're showing it, if we go in the other direction, we would get a negative over negative, which gives me a positive, so it still works. Basically, they're showing that if we switch which was 0.1 and which was 0.2, it still gives us the same answer. Just quickly recognizing what a positive slope should look like and what a negative slope should look like. A positive slope goes up as you move right. A negative slope goes down as you move right. Another way that I've said in other classes is if you were to drop a ball on the hill, if I were to drop a ball from the sky onto this hill, it would roll to the left if it's positively sloped. If I were to drop a ball from the sky onto this hill, it would roll to the right if it's negatively sloped. So positively sloped up and to the right, negatively sloped down and to the right. But everything's seen as I'm moving forward, as I'm moving to the right. Finding slopes of horizontal and vertical lines. If I'm asked to find the slope of the line y equals 3, I see there's no x's in the problem. Y equals 3 is a horizontal line. Horizontal lines have slope 0. So we can do this by looking at the coordinates. If we set up the first point to be negative 2, 3, and the second point to be 3, 3, what's going to end up happening is that y2 or 3 and y1 or 3, when we subtract, are going to give me 0. So no matter what's happening with the x's, my slope formula is going to give me 0 over whatever the subtraction of the x's is. For that reason, I'm going to get 0 as the overall slope, because 0 divided by anything is 0. So for a y equals line, the answer to slope is always slope equals 0. So here we'll see plugging it in, 3 minus 3 over 3 minus a negative 2. Note that whenever you subtract a negative number, you do want to make sure a negative and a negative combine to make a positive. So that's going to happen often whenever your x1 or y1 is negative. When it goes into the formula, since there's subtraction signs in front of them, it's going to make it into a positive. That said, it really doesn't matter what went on down here, because on the top we got 0. 0 divided by anything is going to give me 0. So the slope of the line, y equals 3, is 0. Anytime the y coordinates of 2 points on a horizontal line will be the same, the x values will be different. So every time you have a horizontal line, you're going to get a slope of 0. The opposite's going to happen when we try and do the slope of a vertical line. Because the two x values are the same, the bottom of my slope equation is going to give me 0. Again, that's a mathematical error. That's something your calculator doesn't know how to do. If you put in your calculator right now, 7 divided by 0, and press enter, it'll say something along the lines of error divided by 0. I cannot divide by 0, so really it doesn't give me an answer here. If I tried to use the slope formula with a vertical line, my calculator would say error. I need to recognize that means undefined. The slope of a vertical line is undefined. So x equals line, vertical, undefined slope. Y equals line, horizontal, 0 slope. 0 slope, undefined slope. Using the slope to graph a line, let's say that they tell me that we know we go through the point 2, 3, and we know we have a slope of 3. Well, the first thing that I'd want to do is take that point that I was given and plot it on the coordinate plane. So 2, 4 means starting from 0, 0, move to the right, 1, 2, move up, 1, 2, 3, 4. There's my point, 2, 4. So, first thing, plot the point just like we did in the first lesson this unit. From there, we need to use the slope and convert it to rise over run. We know that 3 really means 3 over 1. So if I'm trying to use rise over run 3 over 1, I want to start at the point that I plotted, rise 1, 2, 3, run 1. That'll get me to the next point, which I can put on my line. Once I have 2 points, I draw the line through them, and then I have the graph of the line. So here it's just showing they changed that 3 to a fraction, so they have it as rise over run. Then they start from their starting point they were given. They move 3 units up, so from 4 they go to 7. You move 1 unit right, so from 2 they go to 3. Graph the line that passes through the point negative 3, 4 with slope negative 2, 5. So we're going to start by plotting negative 3, 4. Here's the point, negative 1, 2, 3, up 1, 2, 3, 4. From that starting point, we know that the slope is negative 2/5. That means we're going to rise by going down 2. We're going to run by going right 5. So here's the rise, down 1, down 2. Here's the run to the right, 1, 2, 3, 4, 5. That means that from our original point, negative 3, 4, we've moved 5 to the right. 5 to the right of 3 is 2. We've moved 2 down. 2 down from 4 is 2. Then after writing the slope is negative 2/5, we see that the rise is negative 2 and the run is 5. From the point negative 4, 3, we move that much and it brings us to the point 2, 2. Then we draw the line to connect them. The last thing we're going to talk about in this unit is how to determine whether a line is parallel or perpendicular using the slope of that line. So parallel lines look like this. They have the same exact slope and they never intersect. The way that I know 2 lines are parallel is when I identify the slopes, I see that they're the exact same. So looking at them graphically, I see that they go the exact same direction and that they're never going to cross. Perpendicular lines meet at 90-degree angles. It's like a street that meets at a traffic light. Just like that is perpendicular. So the way that I tell that something's going to meet at 4 right angles is I multiply one slope by the other, and if I get exactly negative 1, then those 2 lines are perpendicular. Basically that means they're negative reciprocals. What the word reciprocal means. If one fraction is 3 over 4, its reciprocal is 4 over 3. So if I take something that says it has a slope of 3/4, and I multiply it by something else that has a slope of 4/3, 3/4 times 4/3 will give me 12 over 12, which equals 1. In that case, they wouldn't be perpendicular because I got 1, not negative 1. But if it was negative 3/4 and positive 4/3, then when I multiply it, I'd get negative 1, which means that they are perpendicular. So in order for a line to be perpendicular, or 2 lines to be perpendicular, their slopes have to be negative reciprocals. Meaning one of them is positive, one of them is negative, and if I take the first one and flip top and bottom of the fraction, I'll get to the second one. So this is showing 2 perpendicular lines. This line has slope 4/5. This line has slope negative 5/4. You can see that the 5 on bottom is going to the top here. The 4 on bottom is going to the top here. So these 2 are just flipped. This one has a negative. This one doesn't. So these 2 slopes, 4/5 and negative 5/4, indicate perpendicular lines. 2 lines with the same slope are parallel. 2 lines that are perpendicular have a product of negative 1 if that means their slopes are negative reciprocals. Technically, I can't have a negative reciprocal when I have 0 and undefined, but just know that every horizontal line is perpendicular to every vertical line. So if you know you have a y equals line and an x equals line, they are perpendicular. A vertical line and a horizontal line meet at 90-degree angles. Determine whether the line that passes through 7, negative 9, and 10, 2, and the line that passes through 0, 1, and 3, 12 are parallel, perpendicular, or neither. This is going to require us to use a couple skills at once. First thing I'm going to need to do is use the slope formula to find the slope of each of the two lines. So I'm going to start with this as my x1, y1, x2, y2, and do the slope formula for those points. Then I'm going to do x1, y1, x2, y2, and use the slope formula for this pair of points. After I've determined each of their slopes from the slope formula, I'm going to compare the two slopes that I got. If they're identical, then I know that the same slope means they're parallel lines. If one of them is a fraction and the other is the fraction flipped, with one being negative, one being positive, I know they're negative reciprocals and perpendicular lines. If neither of those are true, then I'm going to select neither and say they're not parallel or perpendicular. So going through the motions here, we'll use slope formula on the first set of points, 7, -9, and 10, 2. It gets me to 11/3 as a slope. When I use slope formula on the second pair of points, 0, 1, and 3, 12, it gets me to an answer of 11/3. Since I get 11/3 here and 11/3 here, and these are the same exact slope with the same exact sign, both positive, I can say same slope means that the lines are parallel.